Bienvenidos, Ushamdid, and welcome to this Cisco Networking Academy NetAcad Introduction to Python course supplemental video tutorial. In this video tutorial, we're now going to be moving to part 2 of Lab 4.1.6.13, where we're building a tic-tac-toe application, and in part 2 of the lab, we're going to be focusing on the user entering in their move. So let's go back and refamiliarize ourselves with the requirements of the project. You can see here we've got some information. Again, the information here at the top, not so important right now because we're focused here on the second function that we're working on, which is enterMove. And again, in mine, I'm going to just go lowercase here for all of the first words that show up. I'm going to be changing these to lowercase as I work through my lab. So we're focused on enterMove. And again, the function should accept the board's current status. So we're going to be passing in an argument, which is the list that we've previously defined for the board. Now, we already have, and I think we've got display, we already have the display board function done. We'll test that again to make sure. And again, we're picking up right where we left off. And it's going to ask the user about their move. We're going to check the input. Then we're going to update the board according to the user's decision. Now, we have a nested series of lists. Remember, we have the board list, which is comprised of 3 elements, which are each lists. And so it's going to make it a little challenging for us to go ahead and update the board. I think you'll be happy with the code that we're using. We're going to be focused and leveraging the if-elif structure quite a bit here. And we're going to put things into a while loop, and I'll explain why I'm doing that. It's sort of my reading of the requirements. So again, the board's a 3-element list. And you can see down here, we've got the rest of the requirements. But again, the board has to be a list which contains 3 individual additional lists, right? That represent each of the rows in the table. Now, here's where we're at. The user inputs their move. And so here is what we're focused on for requirements. The user inputs their move by entering the number of the square. And so we know right now we're going to be using the input function. We're going to have to prompt the user for a value for the square, 1 through 9. Now we know that 5 will always be taken because 5, which should be the center square, is always an X because the computer always goes first. So that will never change. Now, we need to make sure that the number is valid, i.e. it must be an integer. Now, we're working in our list board. We have everything defined currently as a string, which means we're going to have to do some explicit type conversion or typecasting, where when we prompt the user for input, we're going to convert that input into an integer value because right here, it must be greater than 0 and less than 10. And it cannot point to a field which is already occupied. And so this code right here is actually pretty straightforward once we sort of get our bearing as to what it is we're trying to achieve. So let's drop out here. Let's get out to the Integrated Development Learning Environment, or IDLE. And here's where we left off. Again, if I hit F5, you can see it prints out our board. So everything looks good with the board. We're now here, and I've dropped in, as you can see, the rest of the functions that we're going to be using. Now, when I read the directions here, we're going to prompt the user, but what happens if the user doesn't enter in a valid number? What happens if the user enters in a string instead of an integer? What happens if the integer is 0, less than 0, 0 equal, less than or equal to 0, or greater than or equal to 10, right? So wouldn't we want to just simply maybe let the user know, hey, you did this wrong, and then loop, right? So continue to run. And again, this is my interpretation of kind of what we're being asked to do here, is that the program wouldn't quit we would give the user some sort of a message. And so leveraging all of the data types and the control flow structures that we've used, this is the solution that I've come up with. So I'm going to put the user into an infinite loop here, right? Until something happens. And the something, the air quotes, something that's going to happen is probably going to be a break. So we're either going to continue if an error gets made, continue to prompt the user if an error is made, or we're going to break once we have the valid input that we're looking for and we update the board, right? So I'm going to say while true, and what are we going to do here? Well, we're going to prompt the user for their move, right? So I'm going to say the move gets input, and we saw this many, many times. Remember, when we're talking about the input function, by default, it returns a string, right? So we have to do the typecasting and flip it from a string to an integer because we're going to have to check. And this is another reason why, if you look up here, right, this is not such a bad thing right now, because if you're thinking to yourself, oh, well, we should have done integers for all of this and then figured out another way to do this concatenation piece, maybe by just using commas outside the strings instead of concatenating. However, remember, input is going to return a string anyway. So we're okay with strings up here right now, and we're fine to do this typecasting because we have to do the typecasting. Even if the integer when prompted, or the user when prompted entered in 1 or 2 or 3 or 4, those are going to be interpreted by default by the input function as strings. So we're still okay. If you were nervous about the board up there, the board list and then the elements, which are the lists, each a list, if you're worried about that, don't be worried yet, right? There's nothing to worry about yet. And so here's what we're going to say. They have over, I think, on the main page, just enter a number, but I'm going to put in something here. Please pick a number within the range of squares. And I'm going to say, let's do 1 through 9. We'll do something like this. And we'll put a little semicolon there and get our 2 parens in there. And so that's what we're going to do. We're going to prompt the user. Now, the first thing we're going to check, and it's interesting, you can see it says here, the number must be valid, i.e. it must be an integer. Well, it may not be abundantly clear right now, but we have done that. This, and we haven't gotten to exceptions yet, so I can't do a try except block of some kind here, right? Because that really hasn't been covered in the course yet. And so again, focusing and using on what we've learned to date, this right here, when I typecast whatever the user inputs, if the int function inside which this input function exists doesn't get something that it can convert to an integer, that's it. The program, it's going to blow up and we're done. Game over. In fact, let me go ahead and drop the call in here for move board. And let's hit F5 and let's see if it even gets to the prompt. I'm just trying to see if it'll show us the prompt here. Yeah, and so you can see here, what if I type in capital L, right? And that's what's going to happen. So the check as to whether or not this is a legitimate integer value is going to happen naturally. Now, is it going to be handled naturally? Are we going to prompt and say something like, oh, hey, this isn't an integer? No, the program is going to stop running, right? So that first check here, right? The user inputs their move by entering the number of the square they choose. The number must be valid, i.e. must be an integer. Check. We've got that covered. And now this is kind of easy, right? It must be greater than 0 and less than 10. So let's go ahead and let's start our if move is less than 1, right? And that's strictly less than 1, meaning 0, -1, -2, -3, or if the move is greater than 9, right? Because again, strictly greater than 9. It can't be equal to 9. It's got to be greater than 9. And so we've covered our bases there. It can't be less than 1. It can't be greater than 9. And that covers all the squares in our board. Now, what are we going to do if this is the case? Well, here's where I'm thinking that we don't want the program to quit, right? We would like to print out a message possibly here saying, please pick a number in the range of 1 through 9, right? And that should be all we would need to say to prompt the user so that they kind of have an idea, oh, I got to pick a number 1 through 9. Now, what am I going to do here? Well, I'm going to continue. Remember that continue keyword that we used, right? The instruction continue. What this means is if the move is less than 1 or the move is greater than 9, we're going to print that message out, and then I'm going to continue. We're going to go right back to prompting the user. Please pick a number within the range of squares 1 through 9. And this is what, again, my interpretation of how this should work is it's going to continue to prompt the user to try to get legitimate, valid input. All right, now, we've covered the if less than 1, if greater than 10, and it cannot point to a field which is already occupied. Now, this one is probably the toughest one of the three things that the two things we've done so far. This third one is probably going to be the most difficult, but let's think about this, right? If I was to say, so what am I checking for first? I'm checking first to see if it's in the range 1 through 9. We've already, again, sort of by dumb luck, the integer function is going to do the check for me to let me know whether what gets entered in can be converted to an integer. So that's going to tell me whether it's valid as an integer or not. The second check, is it less than 1? Is it greater than 9? Right? We've got that covered. And then we've got elif. And so what would be the next thing we're going to check? Now, I'm going to do a little mistake here, right? I'm doing this on purpose, letting you know ahead of time. So how would I check inside of the board? And let's bring that board over here. The board list. So there's the board list, right? And so, if I say board 0, I'm going to see the first element of the list, which is a list with 3 elements. The strings 1, 2, and 3. Not integers, but the strings 1, 2, and 3. And so I know that if I want, if I want to see board 0, and if I want to see the first element of that list, I just piggyback another bracket 0 bracket. And that's going to show me the first element of the list. Now, looking at that list, we know that if I say, B-O-A-R-D, board 0, right, I get that. So then if I keep hitting the up arrow, I apologize because on the Linux command line, if you hit the up arrow, you get the command back. In the integrated development learning environment interactive interpreter, you don't get that. All right, so if I say board 1, I'm going to get the second element, right, which is the second row. If I say board 2, board 2, I get the third element in the board list, which is the third row. So let me ask you this. And again, if you think about it logically, right? What if the user enters in 5, right? Well, 5 is here in the second row, and we know that that spot's already taken. So I'm giving you sort of the scenario here. They're saying, and cannot point to a field which is already occupied, meaning we're going to have to check the current board status, each of the squares, to determine if the square that I'm picking has something other than the move that was entered in, right? And here's what I mean by that. And let me get the drawing tool out here. So if I was to run the program and enter in 5, right? Well, we would want to check this row, we would want to check this row, and we would want to check that row to see if 5, right, this number is not in the row. Because if the number, again, remember, we've already checked to ensure that we're going to get a number the value of which is going to be 1 through 9, an integer 1 through 9. And so if I check and that number is not in these 3 rows, what that means is it's going to be an X or an O. Meaning what? Meaning the square has already been selected. And so if you kind of listen to how I was describing, I'm checking to see if the number, I keep saying enter for user, if the number the user has entered in is not in a row, in other words, is not an element in one of the 3 list elements in board, that means that square has already been selected. And so then we would want to prompt the user again. Again, give them a message saying, hey, it looks like you've picked some stuff that's outside of the range, or for a square that's already been selected. And so here's what I'm going to say. And again, I'm leaving an error in here, and see if you can figure out where we may run into issues here. So elif the move, and here's what we're going to check, is not in board 0, right? And what is board bracket 0? It's the first element in the list board, but what is that first element? It's a list. So I'm checking to see, is the move that they entered not in the first row? And again, how are we going to tackle this? And because I want to check to see if it's in, and let me make sure I've got this right if I'm thinking this through. So if it's in elif move not in the first row and move not in the second row and move not in the third row. And so that's what I'm checking. I'm checking to see if when I say move, it's going to be an integer 1 through 9. And so when we look at this, I'm debating, it's going to have to be and. It can't be in any of the rows. I was thinking for a second I would go with or, but no, because that is not going to be good. So if it's not in the first row and it's not in the second row and it's not in the third row, then that would mean that there's already an X or an O in that spot. And so if that's the case, what are we going to do? And again, remember, we have an error in here. We'll deal with it in a second. Giving you a chance to see if you can see where the issue might be. And I'll say, sorry, that square is already taken. Please select another square. All right. And so we would continue, go back up to the while loop, prompt the user again, and let's see what happens. So we know right now, and we could test this code right now. Let's hit F5 and let's click enter here and get it running. So now here we go. Pick a number. Please pick a number within, let me change that right now. Please pick a number within the range of squares 1 through 9. So what if I hit 5? Because that would be the test, right? Because there's an X in 5. So I just checked all 3 rows. And in all 3 rows, 5 is in the second row. Therefore, I'm going to tell the user, hey, that square is already taken. Please select another square. And so if I were to hit 1, you can see it says that square is already taken. Please select another square. Because right now, give me 1 second here, or do I want to go with or? No, because or is going to hit, or would hit more than 1, because it could possibly hit more than 1. And give me 1 second here. I'm just looking at this code to see. Please pick a number within the range of squares 1 through 9. Oh, right. Okay. So now we're going to deal with the problem that we're going to have is that we are dealing, and this is tied into the problem we've got, right? So I entered in 1, and it comes back and says, please pick a number in the range of 1 through 9. And then it's going to continue, and it's going to prompt the user I'm sorry, it said, sorry, the square is already taken. Let's do Control C. Sorry, the square is already taken. But the problem here is, remember, we do typecasting here. And the input that is selected is going to be converted to an integer data type so that we can do this mathematical check right here. Is it less than 1? If the move is less than 1 or the move is greater than 9, we have a problem. We're going to prompt the user again. What if the move is not in board 0 and move not in board 1 and move not in board 2? Well, remember, right now we're dealing with an integer, so my question to you would be, do we need to convert these, to strings? And when I say these, the use of move. Because in the list, what do we have in the lists? We don't have integers, we have strings. So now let's run this again. We'll hit F5, hit OK. And we may need to add some additional code around this. If I hit 5, you can see, sorry, that square is already taken. Please pick another square. And what if I hit 8? And you can see it doesn't say anything. It says, or I should say, it's going to prompt me again to say, please pick a number, because we're not updating the board yet, right? So again, we're going to typecast move back to a string to check to see if it is not in the board. Because if we're looking for integers, it would never be in the board, right? Does that make sense? We need to say elif the move, which we convert to an integer, which would be like, let's say, the number 5. We're going to convert it back to a string here because that is what we have in our 3 elements of the board list that are lists. Everything is a string, right? Okay, so now we get to the crux of this activity, right? This is kind of the long pole in the tent with respect to how things are going to work. So if I've already checked to see if it's a legitimate integer, and I've checked to make sure that it's in the right range, and I've checked to make sure that it's not already taken in the board, that would mean that whatever was entered in is in the range and is not taken on the board. Therefore, I can update the board with the user move. Now, the question is, how do we do that? Now, remember, over here, if I do a Control C, let me just get out here. Remember, I've got board like this, right? And how would I update one of these elements out of, or I should say, yeah, one of the elements out of the nested lists? How would I update that? Well, remember back to the list chapter. If I was to say board, and we're going to change the X here, let's change that to an O. So if I said 1, board 1 in the brackets, I get the second element of the board list, which is the center row, the second row. And what if I said board 1, and I want that second element of that second list in the board list? I would say 1. So if I say board 1, 1, I get X. Well, at this point, it's pretty simple, right? If I want to change that, then I would say board 1, 1, and let's make it a capital O. And now let's say board. And there it is. And so right now, and again, sticking with kind of the data, the control flow structures that we've seen, we can finish this with the update of the board with elifs, because we've got this nested list that's representing the rows with the 3 elements, each representing a row in the list. And so what if I say elif move is 1, right? Because at this point, by the time we get here, we know that we've got an integer, a legitimate integer that is referencing a square on the board that is not taken. And so if the user entered in 1, then board 0, 0, right? That would be according, let me scoot up a little bit here, right? 0, 0 right here. And actually, where's my drawing tool? So this is going to be from our list. The nested list is 0, 0, 0, 1, 0, 2. 1, 0, 1, 1, 1, 2. 2, 0, 2, 1, 2, 2. And so we know right now how we can finish this out. So let's make that happen. And then let's test this guy. All right, so it's going to be, I'm sorry, I forgot to do the reassignment. So if the user entered in 1, and remember, it's the user, so it would always be an uppercase O, because we're dealing with the user move, not the computer move, which is, computer move is going to be random. All right, so now we'll come back and we'll say elif move is 2. And so 2 refers to what? Board 0, 1. There we go. And if the user entered in the number 2, we would put a capital O, uppercase O in that spot. And again, we're just going to sit here and check and work our way through. Move equal 3. Board, what spot are we going to update? 0, 2. Oops, sorry, forgot that. There we go. And capital O. And there we go. And then elif move is 4. And remember, I'm checking the integer value because that's what we convert it to. We do that typecasting. So now we're down into the second row, right? So it's going to be board 1, 0 would be capital O. Elif move is a 5. The board would update 1, 1. And then that would be set to capital O. And then elif move. And actually, I apologize. So 5 is never going to be selectable, right? So we can skip 5 and go right to 6 here. And then we'll say board 1, 2, right? And that would be the capital O. And again, 5 is always going to be an X because the computer will always go first if move is 7. And so right now we're just dealing with the final row here, board 2, 0, 0, there we go, is a capital O. Elif move is 8. We're going to update the board 2, 1 to a capital O. And elif the move is 9. We're going to update the, did I get that right? 2020 21 2 2. There we go. To a capital O. Now, once we get down here, right, we got to break out of this loop in some form or fashion. And so what we're going to do is we're going to back up and I'm going to say break, because that's going to get me out of the loop. Because again, if we're in this if-elif condition, we've covered every possible condition in here. Not only from the, is it going to be a legitimate integer? Is it greater than or equal to 1 or less than or equal to 9? Is it already a square that's been taken? And if it's not these three things, right, then we're just going to continue to go round and around and around, or the program is going to blow up right there. And then we're going to come in here, because if these three conditions don't match, right, in other words, if it's not a bogus integer, and we're good to go here, then we're going to come in here and it's going to be one move and the board's going to get updated, and then boom, we're going to break out. And that should be, this should function, right? So let's take a look here. And let's hit F5 and let's see what we get. Let's save the program. And there we go. Okay, so let's test a couple things. Let's see. What happens if I don't enter in a good integer? We've already seen that. The program's going to blow up. Let's hit F5. Let's type in, and what's the next thing we're checking for? It's checking to see if it's a legitimate integer value in the range that we have 1 through 9. So if I put 99, no, it tells me, please pick a number in the range 1 through 9. What about 100? No, right? So we can see that that code works. So let me hit a square that's taken. The only square taken is 5. Sorry, that square is already taken. please select another square. And so now we've also kind of got the makings of the code that we could reuse when the computer goes to move, to check to see if that spot is already taken. And so now let's do the next thing that we would do, which is let's pick a square that isn't taken. Let's pick 1. Now, it didn't redraw the board for me. So let's come down here and we would want to go ahead and say display board. Right? So let's have the board show after a legitimate move gets put in. And so now all we need to do is test to make sure that we can update the first square. And there it is, right? Pretty cool. Let's go down here to the second square. Yep, updates the second square. Let's check the third square. And again, I'm going to walk through each of these. Let's make sure we don't have any issues here. And there it is. We updated the third square. Let's go F5. Let's check the fourth square. Works like a champ. Let's check the fifth square. We already know what we're going to see. Square's already taken. Okay, well, let me check the sixth square. We're good to go there. Let's check the seventh square. Works like a champ. Let's take a look at the eighth square. Looks good. And then finally, let's take a look at that ninth square. And there it is. So we just created the code that will keep the user, and again, this is my interpretation of how the game should run, given the fact that there's a possibility they don't enter in a legitimate number. Because again, if we're assuming that they enter a legitimate number in, why are they asking us to check these things? To make sure that it must be an integer, it must be greater than 0 and less than 10. And again, we just said that differently. If it's less than 1 or if it's greater than 9, meaning 0, 10, etc., and so forth and so on. And it can't point to a field which is already occupied. Well, we wouldn't want the program to crash. We would just simply want the program to prompt the user and continue the game. And so that's how I'm reading it. That's the block of code I've come up with. Again, maybe there's some consolidation that we could do here. And maybe there's an easier way for us to weave through. But the fact that we've got these nested lists, I kind of like this because this is all going to be contained in the function. So I only have to write this code one time. Now, this code's probably going to come into play when we get into the computer checking or going to make its move. Because again, when the computer goes to make its move, we're going to have to check to see if that square is taken. And if it is, the computer's going to have to continue until it finds a square randomly. And that's where we're going to go all the way to the bottom here in one of the subsequent videos to check to see, is the computer picking a random square that is not taken up. And so the next function we're going to be dealing with here is make a list of free fields. And so that is going to do it for part 2 of lab 4.1.6.13, right? Tic-Tac-Toe, we've covered the user entering their move, the list gets fully updated, and we are now ready to go on and tackle part 3. Best of luck to you in your studies. Thank you so much for watching, and I hope to see you in the next video.